Hi, Calc BC students. Continuing on with some parametric curve homework problems. We had a request to do number 9. By the way, number 9 is really a tricky problem, algebraically so, really. We've got a lot going on here. Tell you what, I'm going to rewrite this and say y is equal to 3t to the 1/2. We're going to say that x is equal to a negative t plus 1 to the 1/2. There are two parts to this problem. Part A, they want you to find dy dx, which is going to allow you to find the tangent line slope for a curve, which is kind of nice. To do that, you have to take your derivative with respect to t. This will be a 1/2, and we'll have a 3t to the negative 1/2. Chain rule, here we go again. We're going to multiply by the inside derivative, which is a 3. And we will get 3/2. And then down below, we're going to bring down this 3t to the 1/2. That's the square root of 3t. Of course, we have to drop it down. Over here, we can say that dx dt, we're going to have a negative 1/2. We'll have a t plus 1 to this negative 1/2 power. The derivative of the inside with the chain rule is just a 1. So that works out rather nicely, doesn't it? And, then you can see pretty quickly that we'd get a negative 1/2. And then, down below here, we'd have a square root of t plus 1. Well, really what we need to do is find that dy dx is dy dt all over a dx dt. And, we'd have our 3 over 2 root 3t. Right here we'll have a negative 1 over a 2 radical t plus 1. And just to help you out, I hope you can see that this 2 and this 2 are going to definitely cancel each other out. And then what? Well, you've got your 3 over your radical 3t. That's this numerator right here. Then you're going to multiply by this reciprocal. And that's going to be like multiplying by a negative radical t plus 1. Now, undoubtedly, some of you, I'm sure, are probably looking at this feeling a little bit shocked to see the answer. You're probably thinking, now, wait a minute. I have what you have. I have a negative 3 radical t plus 1, and down here I've got a radical 3t. You know what? That's good. That's fine. You could have that for sure. You most definitely can. You might be thinking, well, what is up with this answer that you have on the Google Classroom? Is that wrong? Is this actually going to work? Well, what you really could do is just start to rationalize, and this can look a little funny. We can say, look, I could multiply by root 3 over root 3. And the reason for doing that is really to look at this denominator, because root 3 times root 3 would just get you a 3 coming outside of the radical. And that's what's really driving this whole part of the problem, you can see. You can now see that these 3's, the negative 3 up on top, is going to cancel down below. And now I can distribute that 3. When you've got a radical times a radical, just to help you out, if you have radical A times radical B, that's when you can multiply both of those on the inside. So what are we really going to be seeing there? Well, you could, just get that 3t plus 3 inside of there. And, then all of a sudden you can see that these are going to cancel out. And what are you going to be left with a dy dt? Well, dy dt, if you canceled all that out, you'd be left with a negative 3t plus 3 all over this radical t. And I believe that's what is written down on the Google Classroom. Now, what makes this problem a little tricky is that, this answer right here is absolutely correct. However, this is so important too. I think where most kids, or a lot of kids, maybe would have stopped where I'm highlighting, that'd be a great answer too, of course. I think, the algebra here can get kind of tricky. That being said, let's consider yet even one more answer that we could have. Look, you've got this radical 3. You've got your 3 inside. What if we factored out this radical 3 right here? Kind of reversing what we saw at the top of the page there. And, factoring out that 3 and then pulling it out. And then you could also say, here's yet another answer that we could come up with. You could say, well, wait a minute, what if I put t plus 1 all over a t and then did an I heart math and simplified that? And, inside the radical, we'd have a t over t, which is 1. And then we'd have that. Now, this could look rather weird as yet another answer, and yet this form right here can help us. And forgive me, I just really made a terrible mistake. This is dy dx. This is dy dx that we're finding. So sorry about that. Really want you to be aware of that. That's your slope of your tangent line, right? dy dt we already did very, very simply. So that's your part A. Now your part B. This is where it gets to be a little bit trickier. This is where that second derivative, guys, has this definition. And this is why that last form might be a little bit easier to work with this thing. Why? Because that's really what y prime is. This is y prime. And if I'm going to have to take another derivative right now with respect to t, I could have gone to my yellow form up here and done that. I'd need the quotient rule, wouldn't I? I could go with this answer in the middle for, y prime right here and say, hey, I'm going to take my derivative with respect to t. I'd need a quotient rule. If I've got this form in green, maybe that would be the way to do it because I can avoid the quotient rule. Let's see what we get. This right here is really 1 plus 1 over t to the 1/2. So taking our derivative, we'd bring down our 1/2. We'd have 1 plus 1 over t to the negative 1/2 power. Don't forget your chain rule. What's the derivative of 1 over t? Negative 1 over t squared. And then dx dt. Well, dx dt you just did a little while ago. dx dt is right here in blue. And I'm just going to recopy that. You already did the work for that. It's negative 1 over a 2 with a radical t plus 1. So thank goodness we've done that work. And now the only thing we have to do is clean this all up. And easier said than done, perhaps. But, as we're finishing this problem up, and by the way, thank goodness this is not typical for even what the College Board is going to be asking you to do, because the algebra here is really bad. The negatives are going to cancel out. Look, this 1/2 and this 1/2 is going to cancel out. So that's kind of a, something nice right here. Let's just see if we could quickly clean this up rewriting the top, let's see, I'm going to have this radical 3. This thing is going to come down, and you could say, well, that's going to be like a 1 plus 1 over t to the positive 1/2. This already is going to have a t squared down, so I'm going to put that here. There's a negative right here. I'm going to put that right over this way. But then when you're looking at this denominator, when you're dividing by a fraction, guys, you're really going to multiply by its reciprocal. So you've really got that. So right now, as we're, looking at this, you can think, holy smoke, man, where do we go with this? First of all, it's about to get better in a hurry. I'm going to kind of reverse an I Heart Math. You might remember that this thing right here really was t plus 1 all over a t, right? And, from here, oh my goodness, you can pretty much see where we're going. By the way, if you want to, you could even look at this thing as, a t plus 1 to the 1/2 right now. Maybe you can see why I did that. You can see that some canceling is going to take place, thankfully. And, this becomes t plus 1 to the 1/2. Down here, you'll have t to the 1/2. And then, up here, we're going to have our t plus 1 to the 1/2. And I hope you can see why I did that. These t plus 1s to the 1/2 are going to cancel. You could bring this t to the 1/2 up by that radical 3. However, I hope you're going to see right here that t squared and t to the 1/2, if you just had those next to each other, you would just turn that into a t to the 3/2. And that's the answer that we have for our second derivative. Forgive me if the negative here was not on our Google Classroom answer sheet. If so, it might be very faint. But a long problem, you're not going to have quite as nasty of algebra like this on an assessment or even on an AP.